This video is for exercise 706, integration involving exponential functions. So we've got some rules that the textbook mentions. We know that the integral of e to the x is e to the x plus c. So it's the easiest of all our integrals, really. If you've got a to the x, you get 1 over log a to the x. Now, you would have seen that when you were doing further differentiation in the previous chapter. Don't forget plus c. If it's e to a linear power, and this goes for all chain rule type questions, as long as the power is linear, you can divide by the a, okay? If it's not linear, then we need to look at the chain rule, which is further down here. Okay, so I'm just going to draw your attention to the reference sheet on page 3. So in the left column, we do have these two, and in the right column, we have those two. Now, they're exactly the same thing. They're just in the reverse direction. If the function is e to the f of x, then the derivative is the derivative of the inside multiplied by the derivative of the outside. So that's the standard chain rule. If y is a to the f of x, then the derivative is log a times the derivative of the inside times the original function. From those, you can infer the antiderivative by going backwards, or you can just look in the right column where it's got them written out. If you've got the derivative times e of the function, you get e of the function. The derivative gets sucked back into it, just like it got sucked out of it up there, okay? And the same for a to the f of x there. They are in your reference sheet, so you can memorize them if you want to. You don't have to. You can just refer to the reference sheet. But they are pretty easy once you get used to doing them. So I've got this definite integral here from 0 to 3 of 8e to the x. So the integral of 8e to the x is just 8e to the x, and that's from 0 to 3. So of course we sub in the 3, we sub in the 0. You can put the 8 at the front in brackets if you want to. So it's e to the 3 minus e to the 0. Of course, e to the 0 is just 1. You can leave it factorized or expanded. It really doesn't matter. So 8e3 minus 8 is fine. You can put it in the calculator if you want to as well. It's 152.68. I'm just going to leave it in exact form. Okay, this one, question 2. This is of this form here. That 3 up the front, you can think of it as if it's before the integral sign if you want to. It just stays there for now. Okay, so we just leave it there. So 3 times. Now, if I just follow this formula directly, my function f of x is 2x. So because it is linear, you can just divide by the 2. You don't have to follow the whole chain rule. It works just to divide by the 2, so just don't worry too much there if it is linear only. So let's just follow this. So we do get 5 to the 2x over log 5. We also need that 2, so it's 2 log 5 plus c. Now, if I was in class, I would ask you right now if that's the same as 15 to the 2x. I'm not in class. I'm pausing for a second to see what you think. Pause the video and think about it if you want. The answer is no, it's not. Be really careful. I could have written, if it was, I could have written that as 15 to the 2x, but it's not. It's not the same thing. Order of operations says to do indices before doing multiplication. So they're quite, you can't multiply different bases. It's quite simply just like index stuff. If you want to, you could rewrite it like this, 2 log 5, or you could write 3 on 2 log 5 times that thing, up to you. Okay, one more example. So I've got here something that I'm going to think of as 2 separate fractions. I'm going to separate them out. So I've got e to the 3x over e to the x. So I can just subtract the powers because I'm dividing. So 3x minus x is 2x, e to the 2x minus, same thing, subtract the powers. X plus 1 minus x is just 1, so it's just e to the 1, or just e. That's with respect to x. So if I integrate e to the 2x, my power is linear, so I can just divide by the 2. E is a constant. It's like if I had a 3 there, I'd get 3x. I've got E there, I get EX. And of course, the plus C.